curious about that particular problem, I did send a video out of it when I got here to the classroom today. Okay. Yeah. So guys, I'll talk about that before we leave for the day. So actually, you know what? Let me do this real quick, y'all. So let's see. I did send you guys an announcement on. I think I want to say I sent one on Blackboard. Yes. So the review should be available for you guys. Okay. So I just made the review open, even though we haven't finished chapter 3. It doesn't mean you can't work on the review. It's really going to be the last, so many problems that we haven't talked about yet. But I wanted to give you, in case you wanted an opportunity to get a head start, you could. Okay. So let me put it from the student perspective so that we can see what it looks like from your point of view. Okay, so let's see. Here we go. Weekly activities folder. So we are in week 6. So today, y'all, we're going to go. So let me pull this up today. So today we're going to do 3.8. The homework will be due a week from tonight. Wednesday we'll do 3.9. The homework will be due, a week from that day. The quiz, so the homework for 3.8, y'all, it's open already. I have it open up at the time the class starts. So 3.9 will open up officially on Wednesday at 12:30. So will the quiz. Okay. Quiz has 10 questions. Okay, just like the first quiz did. And then let me go ahead and click on this one right here. So the instructions for the review and the test. So I do have the formula sheet for test 1 right here, y'all. I'm not gonna lie, it's a long formula sheet. What I try to do is basically every one of these little blue boxes that we use for our notes, I threw them in there. So some of them are you gonna need? Yes. Some of them you may not necessarily need. But I just put them in there anyway because it's not like it's gonna hurt. You know what I mean? It might just be more information that you typically need, but it's all gonna be there. So the formula sheet is here, okay? And let's see. So the review has 40 questions and it's due by 12:30 on March the 9th. So the test, y'all, I picked 20 questions and I picked those 20 questions directly from the review. Okay. So when you do the review, if you get all 40 questions done, when you take your test, it's going to be the same questions, right? Now, will the numbers change? Of course, the numbers always change, but it's going to be the same type of problem. Okay. So not only do I want you to, finish your homework and all that kind of stuff, but really what you're going to focus on are those 40 questions. And that's why I wanted to give you guys an opportunity to get started on it early, because 40 questions, hey, I mean, it's not light, it's a lot of questions, right? But, if you do a few questions each day, like you do 5 questions a day, hey, in 8 days you're done, right? I mean, something as simple as that. So that's why I wanted to give you guys a heads up, an opportunity to try it. And then let's see, if you click on the review will open up already, right? If you click on it and hit launch, like you guys taught me, if I didn't know, you should be able to see the questions, right? If you go to the test and you hit launch, it's going to say something like it's not ready yet, right? And it'll be available on the 22nd. And I need to fix that. Oh no, that's the time our class officially ends. That's why. That's why it'll be officially open, guys, when our class officially is over on that day. Okay. And like I said, y'all, that day on the 2nd, that's going to be the day that we're going to use to review. So when is March 2nd? A week from this coming Wednesday. That's why I wanted to give you guys an opportunity to work on it. Again, if I was sitting in your shoes, I would do like 4 or 5 problems a day. So that on that day, on the 2nd, you can say, look, how do I do this one? Or I got it right, but I'm still a little shaky on it. Whatever it happens to be, okay? And I don't think, at the Cal 1 level, I don't really have to tell this to you guys. Got to tell it more like to my remedial math guys or my college algebra guys. But like, we can't come in here and like, sir, can we do number 1? Sir, can we do number 2? Right? Like we couldn't go through all 40 questions. We just wouldn't have time. But that's why I want to give you guys an opportunity to get to have it already, okay? All right, so I already did a whole lot of talking, but let me get down to business. 3.8, y'all, is implicit differentiation, okay? So what implicit differentiation is when we have an equation that we cannot solve explicitly for y, meaning we cannot write the equation in the form y equals something. We can't solve the equation for y, but we can still find the derivative. It's just going to take us a little bit of time to do this, okay? So there is a process on how we do this. So it says to perform implicit differentiation on an equation that defines the function y implicitly in terms of the variable x, these are the steps we're going to take. We're going to take the derivative on both sides of the equation. Keep in mind that y is a function of x. Consequently, whereas the derivative of sine of x is equal to cosine of x, the derivative of the sine of y would be the cosine of y times the derivative of whatever that y value happens to be, which is why, let's see, let me get my pen going, which is why we have that part right there, because we're taking the derivative of whatever the angle is, right? So we have to use the chain rule. The chain rule is something, y'all, that we're going to use a whole lot of in 3.8. And then we're going to solve the equation for dy dx, okay, or y prime. Remember, this is the same thing as y prime. And we'll do some factoring, and then we'll solve. Okay, so look, let's go through a problem so we can kind of see what's happening here. Okay, so assuming that y is defined implicitly by the equation x squared plus y squared equals 25, we're going to find dy dx. So we're going to take the derivative with respect to x on both sides of the equation, okay? Okay, so I'm taking the derivative on both sides, right? All right, let's get started here. Anybody know what's the derivative of x squared? 2x, okay? What's the derivative of y squared? Yes, ma'am. Right, but so this is why every week I make this stuff available to you guys, usually no later than Friday, right? So that when I make this available, what I want you to do is click on this, and you don't need you like this has been available for you guys since Friday, so that you can either print it out or like I know John uses Notability, right, John? That's how you do yours. So if you guys have like an iPad or something like that, you can always download it to that. But I'm making the notes available to you guys a few days in advance. I know Matias is not here, but the other day he ran down to the computer lab and he just printed it out. So if you need to do that, make sure you do that, guys. That's why I'm giving you a few days. I'm giving it to you a few days in advance, right? I'm not actually bringing in paper copies, but I'm making it available to you guys. So make sure you do that, okay? It just makes it easier. But good question. All right. Now, what's the derivative of y squared? Okay, 2y, but we still have to take the derivative of y itself. And that's what we call dy dx, right? Because we don't know what we haven't solved the equation for y because we couldn't solve it for y. Okay? Now, on the right side, what's the derivative of 25? 0, right? Okay. So what we want to do here, y'all, we want to solve for dy dx. So look, I'm going to move this 2x over. Everybody agree that that becomes a minus 2x? Okay? And because I want to solve for dy dx, I'm going to go ahead and divide both sides by 2y, so that now we have dy dx is equal to, y'all agree we can get rid of those 2's? A negative x over 1. And we have found the derivative of that equation, okay? So when we're doing this here, y'all, the one thing that's really important is that anytime you have a y in your problem and you're taking the derivative, you're going to take the derivative just like we did before. Like the derivative of y squared is still 2y, but then you have to do the dy dx because I don't know what the value of y is, and I'm taking the derivative with respect to x. Okay, so we still have to bring in that additional factor of a dy dx. Okay. So to me, so I, guys, before I come to class, I always work out all the problems myself, just so that when I get here, right, there's no surprises. So I had done part of it, last week before, and then I did the rest of it yesterday. And in my experience, or this is what I experience the most, the part that I think is probably going to be the most challenging is honestly the algebra behind it. Taking the derivatives, I think we're probably comfortable enough in like we know what the derivative with the power rule is. We know how to take the derivative of trig functions. I think the part that's going to be the most challenging, honestly, is going to be the algebra, just like moving terms around and isolating that dy dx. Okay. And it kind of gets thrown out the window, right? So yeah, look, so we're gonna go real slow with these problems, y'all, and I'm gonna do my best to help each of you guys, go through this thing here. So look, the problem we have, same type of problem. We're gonna take the derivative on both sides, yeah, of everything. So look, let me zoom in so we can see this. And we're gonna take the derivative. So look, let's go piece at a time. What would be the derivative of negative 10x to the 7th? I could have stayed home, guys. You already know what to do, right? You got the first part done. Okay. Now, we're going to take the derivative of this piece here. Okay. I want you to notice something. Think of this as the first, and think of that one as the second. So remember, when we were using the product rule, when we would do the product rule, we would say we're going to take the first function, which is 3x to the 25th, times the derivative of the second one. Well, the derivative of y would be dy dx, okay? Plus the second function, which is a y, what I want to do now is I want to take the derivative of this piece. So anybody know what's the derivative of 3x or 3x to the 25th? There you go. Okay. Plus, now we're going to take the derivative of y squared. Hey, a little while ago in the problem we just did, we took the derivative of y squared. Didn't we say that's going to be a 2y? And then we have to take the derivative of y itself, so we're going to write our dy dx. Every time we have a y, because we're differentiating with respect to x, and because we're trying to take the derivative of y, and we don't know what y is, we're going to say it's 2 times y times whatever the derivative of y is, right? Now, we're going to do the same thing on the right side. What's the derivative of a negative 6? A 0. Okay. So like I said, y'all, what we're going to do, the hardest part to me in these problems is figuring out the algebra part. So the easy way to do this is, look, anything that has a dy dx, let's put them together. What I mean by put them together is I'm just going to write it like this. 3x to the 25th dy dx plus 2y dy dx. Now, what I'm going to do, the next thing I'm going to do, y'all, I'm going to move these guys. I don't think so, because it's a plus 2y right here. Because it was a plus y squared, and it's still on the same side. You see what I mean? I haven't crossed my equal sign here. So like here's my equal sign. I haven't crossed equal sign. I just kind of put them close to each other, right? But good question. But look, y'all, these guys are going to be equal sign. So when I move that negative 70x to the 6 across the other side, what kind of 70x to the 6 is going to become? Positive, right? Okay. Now, this guy is also going to cross the equal sign. So y'all agree that would become a negative 75x to the 24th with a y? All I did is say, look, let me just bring the y over here. You know what I'm saying? Instead of having the y in front, x to the 24th, x to the 24th y. So again, what did we do? We moved these two terms to the right side, and we left these two terms on the left side. So far, we doing okay? John, am I doing all right? Are you sure? Okay, I'm just checking with you guys. That's the derivative of y, and that's what we're trying to find. We're trying to find the derivative of y. What I want you to be aware of in all of these problems, y'all, because these problems, the way the problems are written, they are not solved for y. So like, I'm going to make this up before. when we had something like y equals x squared plus 7x, and then we were to find dy dx, we would say, when we're taking the derivative on both sides, well, the derivative of y, dy dx, right? Wouldn't that equal to like 2x plus 7? Okay, why? Because the derivative of y is dy dx. So when we did say this problem right here, right, and we said, look, it's the first times the derivative of the second. Well, what's the derivative of y? We always call that dy dx, didn't we? And then plus the second function times the derivative of the first, and then the same thing over here, 2y times the derivative of whatever y is itself. So anytime I have a y and I'm taking the derivative, I can't just put like 2y. I have to put 2y dy dx. I have to take the derivative of y itself, and because of the chain rule. That's right. So far, so good? Better? Okay. So look, y'all. The next thing I'm going to do you agree with me that both those have a term of dy dx? So we're going to factor that dy dx out. Okay? Remember, when we factor it out, it's like if we were multiplying it, right? Or we're actually dividing it out, or whatever you want to say. But look at the factors that we're going to be left with. We'll be left with a 3x to the 25th, and a plus 2y is equal to 70x to the 6th minus 75x to the 24th with a y. Okay. Are you talking on the right side? Yeah, John, there's a lot of stuff we could factor on the right side, but I want to remember what the objective here is. The objective is, can we get this guy by itself? Okay, so look what we're going to do now. We're going to divide both sides by 3x to the 25th plus 2y on both sides, y'all. So now, this piece here and that piece there are going to cancel. Okay. And we're going to be left with dy dx is equal to this rowdy old expression. And there's my derivative. That's where we're going to stop it, yeah. That's where we're going to stop it. Uh-huh. Uh-huh, 3x to the 25th. So think about it this way. I'm gonna come back over here, so just so we can do it on the side, right? So we had a 3x to the 25th and a y, right? Okay, so think about this one here as the first, and think about that one there as the second. Okay, so when you're doing the product rule says, let's take the first times the derivative of the second plus the second times the derivative of the first. Now, I want to point something out here. Look at the operation I have in the middle. What's the operation I have in the middle? Addition. Could I do it like this and it be the same thing? Yeah. So the product rule, which one are you going to take the derivative first? You get to decide. But you're going to take the derivative of one with the second one by itself, and then the derivative of the other one with the first one by itself. You see what I mean? So when I did our problem here, right, I said, look, let's take the first function, which in this case was a 3x to the 25th, times the derivative of the second. Well, the derivative of y is dy dx, right? Plus the second function times the derivative of the first. Oops. Right? Isn't that the derivative of the first one? I'm sorry. And then all I did here was say, look, couldn't I write this like that? Because it really means the same thing. Does that make sense? Yeah, you're welcome. So again, y'all, I think the most challenging part, y'all, let me come back here so that we can leave our derivative as we had it. I think the most challenging part is honestly going to be the algebra perspective of it, okay? I think taking the derivatives, again, I think we're pretty good with that. Again, if you need to go back and reference some of those derivative rules, you want to have that. Again, that was one of the reasons why I uploaded that formula sheet. So again, you'll have that as a reference as you're going through, right? Okay, so let's take a look at the next problem here. We want to find the slope of the tangent line to this curve, and they give us the point at the point -4. Okay, so the first thing we're going to do again, y'all, we're going to take the derivative on both sides. So we're going to go piece at a time. What's the derivative of -4x squared? -8x, right? Okay. Now, we're going to go real slow here. Look at this piece here. I'm going to do that whole first, second business again, okay? So I'll write the first function, which in this case is going to be x, times the derivative of the second one. Well, the second part is a y, so the derivative of that is dy dx, plus the second function, which is y, times the derivative of the first. What's the derivative of x? Almost. What's the number in front of the x? 1, right? Okay. Minus, okay, now we're going to take the derivative of this guy here. 9y squared, one extra part, dy dx, right? Okay. Equals, what's the derivative of a -157? 0. Okay. So guys, before we go on, and I'm going to check in with you guys at home to see if this is making sense. So let me make sure that everybody here is good. So, okay, y'all can hear it. So guys, I just want to make sure. Let me see. Whoa, that's not what I wanted to do. Let's see. Julio, Matias, Noel, Uriel, are we doing good so far?
I'm good,
Yes,
sir.
sir.
Let me can hear you guys. Okay, we're good. All right, good. Okay, just checking with you guys. Just want to make sure y'all are good with this stuff. Okay, so remember what we're going to do now, y'all. We're going to solve for dy dx. So we're going to try to get these two guys together, okay? So again, remember, if it helps, do this so that you know when your signs are going to change and all that kind of stuff. Look, the only time my signs change is when I cross equals. So I'm going to leave these two guys on the left side. So I'm going to write an x with the dy dx, and then a minus 9y squared with the dy dx. But we're going to send these two to the other side. When we cross that equal sign, everybody agree the sign of the 8x is going to become positive? Let me ask you a question. What's y times 1? Y. So when you move that y over, you all agree that y is going to become negative? Okay. Before I go on, are we good? We're good? Okay. Remember what the next step is, y'all. We're gonna factor out our dy dx, right? So we're gonna factor this guy out here. So we're gonna go dy dx, okay, x minus 9y squared equals 8x minus y. Okay. And then how do we get rid of that x minus 9y squared? Divide it out. Perfect. Okay, so now look what we're going to do. We're going to write dy dx is equal to 8x minus y all over x minus 9y squared. Okay. Now, we're almost done here, y'all. The problem says, can we find the slope of the tangent line at the point -4, 3? Remember, when we find our derivative, that is telling me the slope of my line, right? So all we're going to do now, y'all, John was asking about this the other day. When we're evaluating it, now I want you to notice we have a value of x and we have a value of y. So the way we do that, y'all, is this is like the notation that they use. We're evaluating it at the point x is -4 and y is 3. So all I'm going to do here is plug in x is a negative 4 minus y, which is a 3, all over x, which is a negative 4, minus y, which is a 3. Okay. So that looks like a negative 32 minus 3. That looks like a negative 4 minus a 9 times 9. That looks like a negative 35. So I'm coming up with a negative 35 over, looks like a negative 85. And I bet you we can reduce that. So let me grab my calculator. And what's 85 divided by 5? 13 is 17. So I'm coming up with a 7 over 17. Couldn't I divide both of those numbers by a negative 5? And doesn't negative 5 go into 35 positive 7 times? And doesn't 85 divided by 5 go in there 17 times? You see what I'm doing now? Did I go too fast there? So look, 35 over 85, right? If I do this, it gives me a decimal. But if I convert it back to a fraction, 7 over 17. You see what I'm saying? Are we good? Yeah? Okay. So let me ask you a question. Are you guys feeling a little bit better that anytime you see a y, you got to bring in that dy dx factor? Every time it's there, right? And then let me ask you another question. So like, I'm hoping that this first step here is the easy step. Taking that initial derivative, I'm hoping that's the easy step. And the part that we're going to improve on is like, okay, let me get my dy dx together. Let me move the other terms to the side. Let me factor that dy dx out. And then let me divide by whatever I have there. And then I think the other hard part, or at least messy part in this problem, was doing this evaluation, right?
So the one you use to divide, like the equation line,
Uh-huh.
are the ones that don't, the dy dx.
That's right. They're the ones that, that's right. Because I'm trying to keep my dy dx's on one side. So then the ones that don't have the dy dx on, you're right. I'm moving those terms to the other side. You're right. I'm moving those terms to the other side. Okay? So let's take a look here, y'all. We're going to do the same thing, same type of problem. Okay? We're going to go piece at a time. What's the derivative of x squared? 2x. Okay? What is the derivative of y to the 6? Uh-huh. There you go. And then what's the derivative of negative 9? Okay, so remember what John just said, y'all. The part that does not have the dy dx is the one that we're going to move over. So everybody agree we're going to move over the 2f? And when we move that 2x over, y'all agree it becomes a minus 2x? Good. And then the next thing we're going to do is we're going to solve for dy dx. So what would we have to divide by on both sides here? 6y to the power 5. Okay, so those are going to cancel. And I'm going to end up with a dy dx. Y'all agree we can reduce the 2 and the 6? To the 5th? Like this? Yep, you got it. All probably like this. We're going to essentially do the same thing, right? We're doing the same thing. So again, no curveballs here, y'all. Remember, I want you to think about what we've been doing pretty much for the last few weeks. What have we been doing? We've been finding derivatives. We might say, can we find the slope of a tangent line at a particular point? Yes. We might say, can we find the equations of a tangent line at a particular point? That's in essence what we're doing, okay? So no, there's no surprises here, y'all. The idea is we're practicing, we're honing our skills. We're trying to get those skills a little sharper each time, okay? So let's take a look at the next problem that I got here. I'm gonna go real slow. The only thing I'm gonna do differently here, y'all, is when I look at this equation, would it be okay with you if I wrote it like this?
Yeah, sometimes I forget that I'm so restricted to just one paragraph.
Yes. Okay, so the reason why I want to write it this way is because I really want us to understand that when we have those fractions, remember, that's just a coefficient. There's no real difference in how I'm going to compute my derivative, whether I have a 6x or I have a 1/6x, right? Or I have an x over 6, because I can think about it as a 1/6x, right? Okay, we're going to go super slow here. First question, and guys, I don't even want you to reduce anything at this point. What's the derivative of 1 over 16 times x squared? You agree you're going to put a 2 and then a 1 over 16, because that's the one next to it, and an x? Okay. We're going to do the same thing over here. Are you going to put down a 2 and then 1 over 25, and then a y, and then one extra thing? What do we need? dy dx, right? And then what's the derivative of 1? There you go. Okay, now we're going to go slow. Now we're going to do some reducing. You agree that that will cancel with that and we'll have an 8 here? Okay. So let me ask you a question. Now that we've reduced the 2 and the 16, is it okay if I write this as x over 8? Okay. And then can I write this as, I can't really simplify it, 2 over 25 y times dy dx equals 0? Or 2y, whatever you want to do. Okay. All right, what are we going to move over now? X over 8. Excellent. That's going to come to the other side. So look, y'all, we're going to have a 2y over 25 with a dy dx equals, everyone agree, a negative x over 8? Okay. Now, what do we need to get rid of? We got to get rid of the 2y over 25. Let me ask you a question. Can we do this on both sides? Can I multiply by the reciprocal so that those 2 y's will cancel and those 25's will cancel? Because in essence, we've always been saying we're going to divide by whatever we have, but how do we divide fractions? We multiply by the reciprocal, don't we? So now we're going to have a dy dx equals, let's see, that looks like a negative 25x over a 16y, doesn't it? Okay. Now, before I go on, I want us to remember, what was it we're trying to find? We're trying to find the derivative. We're trying to find y prime at what value? At 1. But look what they give me. You see how it's 1 and 4.84? So doesn't that mean that when x is 1, y is 4.84? So right here, y'all, this is what we're going to do. Let's see, negative 25 times 1 over 16 times, what do we say, 4.84? Because didn't it tell me that right here? But y at what value? 1, right? That's my x value on the inside, right? Because my functions are y as a function of x, right? So when x is 1, y is 4.84, right? So now, I'm just going to take my calculator and do this part here. So on the top, I'm going to have a negative 25 divided by whatever 16 times 4.84 is. And I'm coming up with some rowdy old decimal, right? I'm just going to leave my answer like that. I'm probably going to go to like 4 decimal places. So I'd say something like negative 0.3228.
So if you were to rewrite the it would be D1 sorry, D 1.4 over D1.
So the way they're doing this, notice the notation they're using here, John. See how it says y prime at 1? So you would say either y prime at 1 is equal to a negative 0.3228, or you would say dy dx evaluated at the point 1 and 4.84 is negative 0.3228. That would be the notation that you would use. They both mean the same thing. Well, but remember, how did they come up with that 4.84? They plugged in x was equal to what number? X is equal to 1. That was the y number they got, right? That was just the y number they got. Okay. So look, let's take a look at the next problem that I got here, y'all. Again, I'm going to go through the problem the same exact way. Look what we want to do. We want to find the equation, or finding a tangent line to a circle. So it says find the equation of the line tangent to the curve x squared plus y squared equals 25 at the point 3, negative 4. Okay, so first thing is, since I'm looking for the equation of a tangent line, we're going to take the derivative. Let's go slow. What's the derivative of x squared? 2x. Good. What's the derivative of y squared? There you go. Excellent. And then the derivative of 25 is? Perfect. Okay. Now, we're going to leave the part that has the dy dx on one side. So we're going to leave this guy alone, but we're going to move that 2x over. So I'm going to have a 2y dy dx equals, everyone agree, a negative 2x? And then what's my next step here, y'all? What do we need to divide? Divide by 2y, perfect. So we're coming up with a dy dx is equal to, everybody agree, a negative x over y? Right, I can't really simplify that any further. We just got rid of the 2's. We just got rid of the 2's, so that's about all we can do. Now, notice the point that they gave us. They gave us the point 3 and negative 4. So remember what we're going to do now, y'all? We're going to evaluate this at 3 and negative 4. So negative 3 over negative 4, isn't that just a positive 3/4 when I plug in that value? Are we good so far? Okay. Remember what this told us, y'all. Before I go on, remember what this told us? This told us the slope of our tangent line, right? Okay, now we're almost done here. We're going to go y minus y1 equals m x minus x1, right? Remember, this is my x1 and that is my y1, right? All right, so let's go ahead and do this to this. Y minus a negative 4 equals a 3/4 x minus 3. So that's going to become y plus 4 equals 3 over 4 with an x minus, everybody agree, minus 9/4, because 3/4 times negative 3 is a negative 9/4. Okay. And now on both sides, y'all, we need to subtract the 4. Can I write that 4, y'all, as over here? Can I? Oops. can I write that 4 as 16 over 4? Let me ask you a question. Do y'all agree that 16 divided by 4 is still 4? Okay. Why did I write it as 16 fourths? Because I need to get a common what? Common denominator, right? So I said, look, think of 4 as 4 over 1. Well, if it's 4 over 1, you can write it as 16 over 4. And the reason why I want to write it that way is because I need to get those two numbers together, and that's going to be my common denominator. So look, we should end up with a y equals 3 over 4 with an x. Question, what is a minus 9 minus 16? Negative 25, very good, but all over 4. And here is the equation of our line tangent to that circle, x squared plus y squared equals 25 at that particular point. I'm going to zoom out, y'all, because I wanted y'all to see something. They got the same answer we did, so good for them, right? We did it on our own, and we can verify that they got it right as well. You can see here is the equation of x squared plus y squared is 25. Here's that point. There's the equation of our tangent line, right? And we came up with the same exact line, right? We came up with the same exact line. So, what I really want to emphasize, y'all, that's new today from what we did last week or the week before, the part that's new is like this piece. But finding like the slope, we've done that before. Finding the equation of the line, we've done that before. The only part that's really new is that, oh, if I've got a y, I've got to write my dy dx. Tell me, John. If you're looking for like intercepts and stuff like that, that's right. That's how you would find it. Yeah, and I want to say, did we talk about circles at all in pre-cal? I honestly don't remember. Did we? We did. Well, I know we did the unit circle, but what I'm saying is, we did ellipses, we did hyperbolas, we did parabolas at the end. In college algebra, guys, we do circles a lot. The only reason I know that, I'm teaching college algebra right now. I'm teaching like every single semester. And so we did circles a couple of weeks ago, and so I know we do it there. I just don't recall that we did a whole lot of it in pre-cal. But again, you can see all the what we're doing here. We're doing the same process, right? The part that's new is just doing that implicit differentiation, but finding the equation of the line tangent or finding the slope of the tangent line, it's still the same. The other part that's kind of new is that because our equations are have both x's and y's, when we're evaluating it, we're having not only to put that x number, but we're also having to put the y number in as well. Okay, so look, this one is only asking me for the slope. So I'm not going to do the whole thing in terms of the equation of the line. I'm just going to do the slope evaluated at a particular point. Okay, so look, we're going to go super slow. What is the derivative of a negative 2x squared? Negative 4x. Okay. Yes. Now look at this part, y'all. Think of this here as the first, and think of this here as the second. Okay. When you have an xy, think about them as two separate parts, like one function times another one. So we might say the first function times the derivative of the second plus the second function times the derivative of the first. Well, the derivative of 3x is just a 3. Now, y'all, I want you to notice something. I'm putting that kind of like in parentheses or brackets, excuse me, because I have that minus sign in front. And that minus is on the whole thing. You know what I mean? That minus is on the whole thing. Okay? Minus, now we're going to do the derivative of this piece here. What is the derivative of 3y to the third? Excellent. And then finally, we already know the derivative of negative 11 is, there you go. So you're just saying 9y squared, dy dx. Yeah, it's just dy dx times the derivative of y. Okay. So first thing I'm going to do here, y'all, I'm going to go ahead and distribute this negative to both pieces. So I have a negative 4x minus 3x dy dx minus 3y minus 9y squared dy dx equals 0. Okay? Remember what we said. The pieces that do not have the dy dx, those pieces are going to move across. So the 4x and the 3y are going to cross the other side. So we'll still be left with a negative 3x dy dx minus 9y squared dy dx is equal to, everybody agree, a 4x plus 3y? When we cross the equal sign, that 4x and that 3y, those signs are going to change, so they're going to become positive. Okay. All right. Do y'all agree we should factor out the dy dx? Okay. So dy dx, now I have a negative 3x and a minus 9y squared equals a 4x plus 3y. Okay. What's the last step? Dividing, right? Good. Okay. So we have dy dx is equal to 4x plus 3y over a negative 3x minus 9y squared, right? And let's see. And now we're going to evaluate it. Yeah, we're going to plug in, what number are we going to plug in here, y'all? Anybody know? Yeah. Excellent. Good. Let's clean this up. Come on, erasers. Here we go. So we're going to say dy dx evaluated at negative 2, negative 1 is equal to, remember, again, y'all remember, that's the x and that's the y, right? Yeah. And we'll talk about that a little bit later, but yeah, it's different. Okay, so now look, we're gonna start plugging in. So we're gonna say 4 times what? Negative 2 plus 3 times negative 1 all over negative 3 times negative 2 minus 9 times negative 1 squared. Okay. So let's see, on the top, I'm coming up with a negative 8 minus 3. On the bottom, that should be a positive 6 minus 9 times 1. Isn't that still 9? Right, because negative 1 squared is 1, and 1 times 9 is 9. So is anybody coming up with a negative 11 over a negative 3, which is the same thing as 11 thirds? That's the same thing? Jennifer, we doing okay? Yeah? Everybody, we're good? Thumbs up all the way across? Okay, just checking with you guys. Okay, so let me ask you all a question. What do you think is the hardest part of these problems so far? Now, nothing? That's completely new, right? Again, the reason why we're doing that, Jennifer, again, is because the equations that we have, they're not solved explicitly for y, right? So we have, if we're taking the derivatives, so again, before, remember how we when we had a problem that say looked like this, again, I'm just going to make this up: x squared minus 7x. I'll even throw in a sine x in here, right? When we're taking the derivative, wouldn't we say dy dx? Wouldn't we do that already from the beginning, right? And then we'd put 2x minus 7, the derivative of sine is cosine, right? We would do that. So we were actually doing that already. It's just that now that y is appearing in the equation, right? So we can't forget about it. We're still doing the same thing. We just can't forget that it's in the equation itself, right? Okay, so look, let's take a look at the next one here, y'all. Again, we're going to go slowly, one piece at a time. Okay, so it says, use implicit differentiation to find dy dx without solving for y. Okie dokie, let's do it. One piece at a time. What's the derivative of 5x squared? 10x. Okay. What's the derivative of 3x? 3. Okay, don't forget this part here, y'all. Remember, first and the second. So we said, the way we did the derivative of product, it's the first times the derivative of the second plus the second function times the derivative of the first. Well, the derivative of x is just 1, isn't it? Right? And then the derivative of 155 is 0. All right. Now, remember what we said. Anything that does not have a dy and dx is going to get moved across the equal sign. 10x is going to move. The 3 is going to move. The y is going to move. So we'll be left with an x dy dx is equal to a negative 10x, a minus 3, a minus y. Okay. And now we're going to divide both sides by x. So those will cancel. So we're going to have dy dx is equal to negative 10x minus 3 minus y all over x. We can't go any further, yeah. And then that's going to be my answer right there. Now, look at the next part. At the given point, find the slope. Okay, so look at the notation they're using, right? They're saying, what is dy dx evaluated at the point 5, 3? So remember what that means. Everywhere we have an x, we're going to plug in a 5. Everywhere we got a y, we're going to plug in a 3. So negative 10 times 5 minus 3 again, all over a 5. So let's see, that's negative 50 minus 6 over 5. Anybody coming up with a negative 56 over 5? And that's going to be my answer right there. So again, y'all, before I keep going, compared to where we were minutes ago, say half an hour ago, 45 minutes ago, I'm hoping that as we're going through these problems, the idea is becoming easier. It's becoming like, okay, take the derivative. If I see a y, I can't just take the derivative. I got to write my dy dx, right? And then anything that doesn't have a dy dx, move it to the other side. And then if I have to factor out my dy dx, do it, and then divide. And then if it tells me to evaluate, plug the numbers in, and we're good to go, right? They're all the same type problems, right? They're all the same type problems, right? So what's going to be the hardest part here? I think it's just the computation of it, right? But again, I wanted to do these problems all just again, so you have the idea of how to go through them. Again, you know, like if I were sitting where you're sitting, if I was where you guys were, my first step would be I would write it like this. That would have been my first step. Why? Because I don't want to get confused with the fraction part of it. And then when I start taking my derivative, I would say, look, 1/4 times 2x plus 1/16 times 2 with a y, and then a dy dx is equal to 0. Right? Like that would have been my first step in this part. And then the next thing I would do, I'm just going to start simplifying things. So I know I can reduce that 2 with that 4. So that's going to give me an x over 2. And I know I can reduce this 2 with that 16. And that's going to leave me with a y over 8 with a dy dx equals 0. And then I'm going to move this whole piece over to the other side. I'm going to have y over 8 dy dx equals a negative x over 2. Question, anybody know how I'm going to get rid of that y over 8? What would be my... Very good. Multiply 8 over y. Perfect. So now we have dy dx equals, let's see, 2 goes into 8 4 times. Everybody agree a negative 4x over y? Okay, and then the last step here, y'all, we're just evaluating it at that particular point, right? Evaluating it at 1 and 3.46. So that's going to be a negative 4 times 1 over a 3.46. I don't know what I'm going to get, some kind of decimal. Let's see, negative 4 over 3.46. And I'm coming up with like a negative 1.1561 if I go to 4 decimal places. Yeah. That's what I came up with. All right. Okay, so let's take a look at this next one here, y'all. We're going to go real slow just to make sure that we're good. Yeah, and then when I divided it out, I came up with a negative 1.1561. $61? Right there? When I divided it out? I think so. Okay, so look, let's take a look at the next one here. So we're going to go super slow here, y'all. Look what we have inside. We have x plus y to the fifth equals x to the fourth, y to the fifth. Okay, so we're going to use the chain rule here. We're going to go real slow. Okay, what is the derivative of x plus y to the fifth? 5. X plus y to what power? To the fourth. Now we have to take the derivative of what is inside. Okay, so we're going to take the derivative of what's inside. What's the derivative of x? What's the derivative of y? There you go. You've done the first part. Okay. Good. You did the first part. Awesome. Okay, now let's do the second part. So remember, y'all, I'm going to think of the x to the fourth as my first, I'm going to think of the y to the fifth as my second. So the derivative of the product rule says, let's take the first function, which is x to the fourth, times the derivative of the second. Well, the derivative of y to the fifth would be a 5y to the fourth times the dy dx. Okay. Plus the second function, which is a y to the fifth, times the derivative of the first one. Well, that would be a 4x to the third. Okay. All right. So now we're going to go real slow. Look, y'all. Since this part is in parentheses and it's being multiplied, we're going to go once, and then we're going to go twice. So I'm going to write 5x plus y to the fourth. When I multiply by 1, it's the same thing, right? And then plus 5x plus y to the fourth times dy dx. Okay? So all we did is do a little distributing there. Okay? I'm going to fix this piece here, y'all. Instead of x to the fourth, 5y to the fourth, dy dx, or written like that, I'm just going to write it 5x to the fourth, y to the fourth, dy dx. Plus 4x to the third, y to the fifth. Okay. Jennifer, are we good? Because isn't this right here being multiplied by both of them? Right? So how do you distribute? 1, 2, right? So that's why I got them plus. Right? Because that's what distributing means to do. Brother. Okay, now look. Let me ask you a question. Yeah, we're going to do some factoring, but hold on. Remember what we're trying to do? We're trying to get what by itself. Okay, so let me ask you a question. If I leave this piece alone here, 5x plus y to the fourth dy dx. Okay, I'm going to leave that piece alone. Can I bring this guy from the right side to the left side because it also has the dy dx? And if we bring it over, what's going to happen to the sign? So it's going to become a minus 5x to the fourth, y to the fourth, dy dx, right? Okay. Equals, now, I'm going to leave this guy alone. I'm going to leave that 4x to the third, y to the fifth alone. But can I send this guy to the right side? Because it doesn't have a dy dx. And when I move it over, wouldn't it become a negative 5x plus y to the fourth? Okay. Second question. Can we factor out a dy dx on the left side? So we're going to have a dy dx, and then inside we're going to have a 5x plus y to the fourth minus 5x to the fourth, y to the fourth. Okay, equals all that funky stuff over here. Okay. So far, so good? Okay, one last step. What do we say the last step is? Divide. We're going to divide by that whole big thing right here. 5x plus y to the fourth minus 5x to the fourth, y to the fourth. Right here. 5x plus y to the fourth minus 5x to the fourth, y to the fourth. Okay. So this is going to cancel. I'm just going to write my answer over here on the right, y'all, because I'm running out of room. to give myself more space to do this problem. dy dx equals 4x to the third y to the fifth minus 5x plus y to the fourth over 5x plus y to the fourth minus 5x to the fourth y to the fourth. Okay. This is my answer for the first piece. Okay. I don't know. We'll figure it out right now. I have no idea what the answer is going to be. But yeah, it looks, when we do the evaluating, yeah, different powers, right? Okay, so look, y'all. Second thing we're going to do, we're going to take that same problem, dy dx, and we're going to evaluate it at what point? Give me a hint. 2, 3, right? So let's come back over here, and we're going to evaluate it at 2 and 3. Okay. Remember what that means. Everywhere we have an x, we're going to plug in a 2. And everywhere we have a y, we're going to plug in a 3. Okay. All right. Everybody agree this next part is pretty much going to be calculator work? So look, let's do it in pieces. So we're going to go 4 times 2 to the third times 3 to the fifth. So that's giving me 7,776 upstairs. Okay. Question, y'all. What's 2 plus 3? So that's only a 5 right there, right? So isn't 5 times 5 to the fourth really the same thing as 5 to the fifth? 3125? Again, I'm just doing my calculator. This number is going to be the same thing. That's still 3125 down there because that's what I got right here. So 3125 minus, let's see what the next part is. So 5 times, what is that? 2 to the fourth times 3 to the fourth. Okay, and I'm coming up with 6480 down here. Okay. All right, 7776 minus 3125 is 4651 upstairs over whatever the bottom number is. It's 3125 minus 6480, 3355. Okay, and guys, when I'm ending up with numbers like this, I'm probably going to again do decimal approximation. So 4651 divided by negative 3355. I don't think I can reduce that fraction, and even if I could, I don't think I'd want to. Yeah, it won't reduce. So I'm going to come up with a negative 1.3863. Does that sound reasonable? Let me see. let's see, when I divided them out, I came up with a 1.368289
Why is your answer not positive?
because I did it a second time with only doing positive numbers.
Um,
Did you come up with 4651 over 3355 with a negative?
yeah, I was like, well, I'm trying that.
No.
Just one thing. Why do you use significant figures to find out that
Why are we or aren't we? I think so. When I've been checking checking the problems, a lot of times, I mean, they'll put a bunch of decimal places. I'm just going to 4, right? I'm going to 4 because I figure 4 is usually good enough. So that's what I'm using. I'm using 4. Okay. Okay, so now look, y'all. What did we just find? I know we took the derivative, we plugged it in. What did we find, though? Slope. Excellent. This gave us the slope of our tangent line, right? Okay. Now we're going to find the equation of the line, right? Isn't the point 2 and 3 the point that we had? So I'm just going to go y minus 3 equals a negative 1.3683 times x minus 2. So 1.3683x. And then that number times a negative 2 should be a positive answer. The negative 1.3863 times a negative 2 is a positive 2.7726. And then we're going to add 3 to it. I don't even need my calculator for that part. Because that should be a 5.7226. And there we go. And there's the equation of our tangent line. What was the hardest part of this problem? The plugging in the numbers, right? You know what that is? That's calculator work, right? That's just calculator work. It's not hard. It's just messy, right? So that's where we got a calculator. That's where you take your time with it, right? If you feel like, hey, you know what? Maybe my answer is a little sketchy. Try it again, right? Do the same. Do the steps again on your calculator. Make sure you're coming up with the same numbers. Go real slow, right? It's not a race. Just take your time with it, and that's the numbers we're coming up with. I think the derivative was a little more challenging in this problem too because we had that x plus y to the 5th, right? So we had to do that, and then we had in this problem, y'all, we actually had a dy dx on both sides, so we did have to move some stuff over. But again, I think we've probably become comfortable enough in moving terms across the equal sign. The hardest part again was just, hey, let's do that evaluating, right? And again, I wouldn't say it's hard. It's just like cumbersome, messy. Okay, so take a look at the next one we got here, y'all. It says find or use implicit differentiation to find dy dx for y squared equals a negative 2y minus 7x, right? Okay, first piece. What's the derivative of y squared? Uh-huh. There you go. Okay. Equals. All right, we're going to do the same thing here. What is the derivative of a negative 2y? Excellent. Very good. Negative 2 times dy dx, right? Plus, the derivative of 7x is just, there you go. Okay, remember what we said, we want to get all the dy dx's together. So we're really going to take this guy and we're going to bring it over to the left side. So I'm going to leave that 2y dy dx alone. And then when we cross equal sign, that becomes a plus 2 dy dx is equal to 7, right? And then does everyone agree that we can factor out that dy dx over here? And we should just be left with a 2y plus 2 equals 7. If you factor out that dy dx, okay. And then finally, the last step we always said was we're going to do what? Divide. So we should be coming up with a dy dx is equal to 7 over 2y plus 2. And look how simple it was, right? But again, you know, and honestly, all the problems, in my opinion, are going to be relatively simple. It's just remembering to include that factor of dy dx, and also, you know, the part that again is more and again, it's not hard. Like the problem we did a while ago, it wasn't hard. It was just messy. Like I had to use my calculator. Okay, you know, we've been messing with our calculators ever since we were kids or whatever. Guys, one thing I do want to mention is when you're doing your problems in the homework, you know how it has like there's a little video you can watch of a separate problem. Okay, I'm going to make up a problem here, y'all, just because I want y'all. Oh, we're not done yet. Okay, so I'll tell you what. Let's see. I thought we were done. Okay, we got 2 more. So instead of me making up a problem, I'm going to show you how sometimes the notation that they use sometimes can be slightly different. Okay, so let's take a look here. I thought we were done. Sorry. Given the equation below, find dy dx, and then find the equation of the tangent line. Okay, so we've done this probably enough times to know how to do this. First step. What's the derivative of 15x squared? 30x. Okay. Remember, I'm going to do this in pieces, y'all. I'm going to call this the first. I'm going to call that the second. Okay. So when I'm taking the derivative of 10x to the 75th y, we're going to say it's the first function, which is 10x to the 75th, times the derivative of the second. Okay, so you know how we've been using dy dx for the derivative of y? Sometimes, again, I'm just going to show you this way because sometimes in the videos, this is what they do. Instead of dy dx, isn't dy dx the same thing as y prime? Sometimes they use that notation. Now, the only thing I'm going to tell you all is be careful if you decide to use the notation. Guys, a lot of times when I did the problems, like, so John was in my class last semester. He told me about notability. I got notability. So like when I was working through this yesterday, just so that again, you know, I'd be fresh when I came in, I used the y prime notation a lot myself. The only thing I tell you all to be cautious with is to understand y prime and y are 2 different things. It's again, y prime is the same thing as dy dx. Sometimes if you're a little, and y is f of x, right? So if you're a little messy with your notation, sometimes people see a y and a y prime next to each other, and then they're like, oh, that's a y squared. You know what I mean? Because you were a little careless with the notation. That's the only thing I'm going to caution you on. Okay, plus the second function times the derivative of the first. Well, what's the derivative of 10x to the 75th? 750 x to the 74th. Okay. Plus, everybody agree, 5y to the 4th, and then a y prime is equal to 0. Okay. Again, y'all, if you don't like using y prime, write dy dx. I just wanted you to be aware that, again, if you watch the videos, a lot of times they will use y prime. It means the same thing. Remember what we said we're going to do? We're going to get the derivative pieces together on the same side. So I'm going to leave this guy here and this guy here alone. So 10x to the 75th with a y prime plus a 5y to the 4th and a y prime equals, now the ones that don't have y primes, we're going to move those over. So this 30x to the 6th and this 750x to the 74th with a y, they're both going to move across. So that'll leave me with a negative 30x and then a negative 750 x to the 74th and a y, right? Because I crossed equal sign, y'all, my signs change. All right, second question. Y'all agree that we can factor out a y prime out of here? Okay. So y prime 10x to the 75th, 5y to the 4th equals negative 30x minus 750x to the 74th with a y. And then the last thing we're going to do, y'all, is we're going to divide, right? So we're going to divide by a 10x to the 75th plus a 5y to the 4th on both sides. Aren't we dividing?
Oh, I forgot that you also exactly.
Okay, you've been doing it, and you're using dy dx, John? Yeah. And again, if it makes it easier just to keep that same notation, do it. Okay. I just wanted you to be aware that when you're doing the problems, y'all, and you're watching the video, if they are using y prime, if they're using y prime, it's the same exact thing as dy dx. Okay. It's just another way of writing it. It's just like when we were in algebra, a lot of times we would write like, y equals mx plus b, and then sometimes they write f of x equals mx plus b. Two different ways of writing the same thing. Okay, we found our derivative. Okay, so if you're using dy dx, you're going to have dy dx equals negative 30x minus all that stuff over all that other stuff, or you're going to write it using y prime. It's the same thing, right? Okay, second question says, let's find the equation of the tangent line to the curve at the point 1 and 1. Okay? So, if we wanted to find the equation of the tangent line to the curve at the point 1, 1, what's the first thing we're going to do here? Plug in the 1, 1, right? Okay. So, when we're going to plug in the 1, 1, negative 30 times 1 minus 751 to the 74th times another 1 over 10 times 1 to the 75th minus 5 times 1 to the 4th. Okay, everybody agree that 1 to any power is still going to give me 1? So if this is going to give me a 1 and that's going to give me a 1, what number would I end up with upstairs? Anybody know? Minus 750, wouldn't that be a negative 780, right? Okay, and on the bottom, if 1 to the 75th is 1 and 1 to the 4th is 1, 10 minus 5 would leave me with a 5, because I'm just plugging in the number 1. Okay, and then the last thing I'm going to do is I'm going to divide that out. So 780 divided by 5, negative 157. It's okay. Ah, that was my bad. You're right. My bad. That was a plus right there. I made a mistake. Oops. That was a 15, right? Okay, never mind. Oops. Let's see. Okay, yeah, 52, right? Yes, you're right. Ooh, I put 785, but it's 780 divided by 15. Yes, you're right. Thank you. 52. Excellent. My bad. Okay, so negative 52 is our slope. This is the slope of the line. And remember, look at what the question is asking me to do. The question is asking me to find the equation of the tangent line at that point, right? So now we're going to go ahead and find the equation. Again, we've done the hardest part. This part here should be the easy breezy cover girl part, right? So yes, let's go ahead and do that. So let's see, y minus y1 equals mx minus x1. So y minus 1 equals a negative 52x minus 1. Oh, let's see, negative 52x plus 52. And if we add 1 to both sides, there you go. And we got the equation of our line. Okay. Manageable? Yeah. Gets a little messy, right, with some of the computations, but like in this problem, y'all, you know what was the nice part about it? Look at the point that they gave us, 1, 1, right? The fact that it was the point 1, 1 made that computation a lot easier, right? Because we're like, oh, we're just plugging in 1. Whereas the other one, you know, we had to plug in like 2 and raise it. You know what I'm saying? We have a bunch of calculations here. I was like, oh man, that's just much easier. Again, guys, you can see I make mistakes too. I put a minus right here and it should have been a plus. So I tell you what, this problem here, this is the last problem. It's almost identical to the one we just did. I'll tell you what, let's at least do the first part because I think you guys can probably handle the second part on your lonesome really, really well. Uh-huh.
I kind of was lagging behind from the previous problem.
Uh-huh.
So could you go to the one before it?
What part?
The previous problem.
Oh, the one before this one? This one over here?
Oh, okay. One thing. I wasn't sure if you were going to do like a y center over y over
We're good?
and then the previous problem, we used the way around this.
Which one? The one that we did before this?
Yeah, the one called
Here we go. Yeah. Because it's a minus 3, right? Yeah. Okay, so look, y'all, let's do the first part of this one again. I'm pretty confident we can handle the second part. But let's do the derivative again, just to make sure that we're good with this stuff here. I'm going to continue using that y prime notation, y'all. Again, my point though is when you're doing this, you get to decide. If you like using dy dx, use dy dx. If you like using y prime, use y prime. Just if you are using y prime, just be careful that you don't like combine it with a y term. Okay, that's the only thing I always, I think you just need to be a little cautious with. So 22 times 5 is like what, 110? X to the fourth? Okay. Again, y'all, I'm going to think of that as the first, and that is the second. So it is the first times the derivative second, plus the second times the derivative of the first, whatever 9 times 55 is. Okay, thank you. 495? Boom, awesome. 495. 495 x to the power 54. All right, good. Plus, everybody agree a 2y and a y prime, and then a 0 on the other side. Okay. Yes. And then remember what we're going to do now, y'all. We're going to get our y primes together, or our dy dx's together, whatever notation you're using. So I'm going to leave this as a 9x to the 55 with a y prime, and then a 2y with a y prime, and then the ones that don't have the y primes, they're going to move across the equal sign, right? They're going to move across the equal sign. So when I move that 110x to the fourth, it should become a negative 110x to the fourth. And then everybody agreed that's going to be a minus 495 x to the 54th with the y. Okay. All right, and then on the left side, do y'all agree that we can factor a y prime out of both those two pieces? So we should have a y prime or dy dx, whatever notation you're using, x to the 9x to the 55th plus a 2y equals that negative 110x to the 4th minus 495x to the 54th and a y. And then the last step, y'all, John says we're going to divide by 9x to the 55th and a 2y and a plus. I don't want to make the same mistake I made before and change the sign. It should be a plus. Okay. So here we go. Y prime equals negative 110x to the 4th minus 495x to the 54th with a y all divided by 9x to the 55th plus 2y. And that would be our answer, y'all, for the very first piece, right? Boom, that would go right there. And then again, if we wanted to do the second piece, which I know we can do, we're going to plug in x equals 1, right? And plug in x equals 1, y'all, should be really, really easy for us to do. I'm sorry? So notice what you're writing here. Look what it says here. dy dx, right? Isn't dy dx the same thing as y prime? Equals. What did we end up with? Oh, okay. Yes. So what I'm going to do now, I'm always going to do the second part, John. Right? Negative 1.
Can you write it as y prime parentheses 1?
Yeah, y parentheses 1. Just know that you're plugging in. So, guys, John's question is, when you're evaluating this thing, can he write it like this? You can, right? You can. But you have to understand that this value here stands for what? But which variable? That stands for the x, okay? So then you have to ask yourself, what was the y value? And they gave us the y value as well, didn't they? Because they told me that the y value was what? Also 1, right? So you can write it that way. Just make sure, but again, I want you to notice something. So look, y'all, a couple of things. So John's question really is, it's more like a technical question in terms of the way you're evaluating it. Let's see if I can find it, because we did one earlier. Here we go. So John, I want you to take a look up here real quick. Okay. See how they're writing it like that? That's usually when you have implicit differentiation, that's going to be your format. But I want to point out earlier, let's see if I can find it. They did the thing right here. They used that same notation, right, in another problem. But, oh man, where is this? You did it earlier today. Here we go. They did use this as well. If you take a look up here, John, they do have y prime. Take a look up here real quick, though. They do have y prime at 1, but I want you to notice something. They also gave me what the y value was, right? Because I'm using both x's and y's, right? What notation do you use? You get to decide. It's the same thing as, do you want to write y prime or do you want to write dy dx? You really get to decide how you're going to do it. Okay? All right. So then again, y'all, you'd plug in your numbers and you'd figure out what you're going to get. I'll give you a hint. Bottom number is going to be 11. I know that because they're plugging in 1, right? Top number is going to be something like, I don't know, negative 605 on the top. Anybody got a calculator? Oops. See if it divides in nice and neat. Does it divide in nice and neat? I hope it does. Negative 55. Okay. And then you can plug in your y equals, y minus y1. Again, so guys, even these problems here, like, I'll tell you what, I like these two problems, right? Like these two problems here, again, the derivative was a little messy, but evaluating it was pretty easy breezy come a girl, wasn't it? Yeah. Okay, so again, y'all, before I stop recording or anything, I want to come back to just a couple of things here. So let me see. Uh, okay, so 3.8, y'all, the homework is already there. So again, just to give you a heads up, the homework for 3.8, y'all, is due a week from tonight, right? Wednesday, I'm going to cover 3.9, right? So Jennifer, one thing you were saying about getting the notes, remember, you can always do this, click on them. So if you want to put them out, this way you already have like a paper copy, so you're not having to write everything down. You can do that. Computer lab is right here. We're going to go through this stuff here, y'all, on Wednesday, okay? The other thing I wanted to mention is, let's see. So up here before, I called it like trig stuff and formulas. I just changed it to formula sheets and chapter notes, but it's the same thing. So trig identities, I have those trig identities up here. So again, you'll have access to that. The table of trig functions, we already had access to that, right? This one here. Formula sheet for test one, I put it up here as well. So it's in that one, like the one the review is, but I also put it over here as well. So in case you need it, it'll be there. And then y'all, the other thing I did is I put all of chapter 2 notes in one document. So instead of having to look for like 2.1, 2.2, 2. I put them all in one document. So all of chapter 2 is together. The only reason I hadn't done it before, y'all, I'm basically staying like a couple of weeks ahead of you guys. So like if you were to ask me, hey, do I have the notes for chapter 4? I got the notes for 4.1, but I don't have them for all of chapter 4, right? But when I'm done, then I'll put them all together into one document. But I got all the notes for chapter 2, right? And when I made that formula sheet, y'all, really what I tried to do was, let me see if I can find something here. Like I would try to, like I would copy this, right? Copy those little things in there. Now again, are you going to need every one of them? You may not. But I didn't want to remove stuff because if one person needs it and the other person doesn't, and then I pull it out, well, it's not fair to the person who really felt like they wanted it. If you don't want it, scroll past by it, right? Same thing for chapter 3, y'all. I have all the chapter 3 notes right here together. So again, it's all in one document. But I just wanted to give you a heads up. I put that there, and then again, the quiz, y'all, will open up on Wednesday, Solo 3.9. The review is already open. Again, it's got 40 questions. It's not due until the 9th at 12:30, and that's when our test is due as well. So just to give you guys a heads up, Wednesday we're going to cover 3.9. Next Monday, I'm going to teach you something brand new, but I'm probably not going to make it due until we come back to spring break. Okay, and the only reason I'm going to make it due after spring break is between now and next Wednesday. What I really want you to do is focus on, finishing up your homework, doing your quiz, working on that review, and then next Wednesday, y'all, all we're going to do is just go over questions from the review. Whatever questions you don't understand, we'll go over it. We'll make sure that you guys feel good, and then the test will open up. And then, like I said, that one day we won't meet. But I have it. I think I have all that kind of fun stuff here. Let's see. I guess I didn't put it in here, but I'll put it in here about the day we're not going to meet. That's me giving you the day to take the test. Okay. But does that sound good? Are we clear on what we got to do? Yeah. Okay. So guys, let me go ahead and stop recording.